Today I'm going to talk about how we made use of neural generation to have social conversations. I'm Ashwin again, and I was the co-lead for Stanford's team, Chirpy Cardinal. I'm a PhD student at Stanford. So, to give some background about the Alexa Prize and our bot, Chirpy Cardinal. So, in the Alexa Prize competition, universities create a social bot, which is an Alexa skill that converses coherently and engagingly with humans on popular topics and news events. So, users would say, "Let's chat" to start chatting, and they would be randomly paired with one of their teams. And they can chat for as long as they want. There is no predefined goal or topic, but the teams are expected to support topics that come up typically in social contexts. This is a unique opportunity for any university because we don't really get to chat with users all that often and then get informed by them. So last year was Stanford's first year participating in this competition. We started from nothing really, but then we ended up at the second place, and we were able to beat existing teams that had been in the competition for 3 years. We believe that this is made impossible by part because of our use of neural generation that allowed us to quickly bootstrap and be competitive with rules-based systems that had been tuned over the years, and also in part because of the way we organized our code, people, and processes around quick and iterative development. So in this talk, I want to give you a sneak peek into these two aspects that are unique to our bot, Chirpy Cardinal. So social interactions, right? They're central to our day-to-day lives. As social animals, we crave for a deeper connection with the people around us. Even if you think of goal-oriented interactions, they become a lot more engaging, especially for customers. When shopkeepers are chatty and then they talk to us about our lives. The grocer who tells me about their favorite bread. Maybe it's a retail salesperson who helps me find the right piece of jeans for me, or maybe it's my barber who listens to me about my day-to-day frustrations. I like going back to them again and again because I feel like they care for me. And that's why social interactions are really important, even with task-oriented dialogue systems. And here, I'm not talking about single one-turn canned responses. I'm talking about multi-turn, richer, and more substantial interactions. The way I think of task-oriented dialogue is like taking a walk to your favorite coffee shop. You typically know where you want to go and perhaps even how to get to it, right? There exists a happy path. You get there with intents, slots, frames, templates, canned responses. Maybe you have an intent classifier that gets you an intent. Maybe you find out the right questions to ask. Maybe you extract some slots. Maybe you fill in the slots into the response templates. Now, when I think of social dialogue, I think of taking a walk in the downtown. You don't know what you're looking for. It's more serendipitous, exploratory. Maybe you see a signboard here. Maybe you check out the menu in another restaurant. Maybe you go to that coffee shop, check out the ambiance. Maybe you end up finally at a dessert shop. Here, you need to go beyond intents and templates. To give you an example, consider the same question. How was your day? Asked to 3 different people. The first one says it was tiring. I had too many meetings. But the second one says, I went to play in a park. Perhaps they were a child. The third one says, I think it went well. I just had dinner at a restaurant. You can see users can respond in a variety of different ways. They have different emotions. They are coming from a different place. They might have had different life experiences. They are very unstructured and they don't really have an intent. They are just telling you about their lives. The bot responses in turn need to be custom fit for each user response. So for the first one, you might want to be empathetic and say, I feel you. It can be very taxing. Hopefully you can get some rest tonight. Maybe for the second one, you can ask about what they played. And for the third one, since they had a dinner, maybe you can ask, what did they have for dinner? Now, let's say we change each of the user utterances just a little bit. So the first one becomes video calls instead of meetings. Now the bot response needs to reflect that. So you can say it can be very taxing to stare at a screen all day. Maybe in the second response, they talk about their younger sister. So now the focus of the conversation has shifted to that younger person, and you might want to ask, how old is she? Maybe in the third one, the user just added dinner date instead of dinner. And now the focus has completely shifted to it being a date and how you can talk about that other person. So you can see that you need to go beyond intents and templates, beyond the structure, and neural generation helps us get there. So give you a 101 about neural generation and how it works. You typically have a large language model, let's say GPT-2. You feed the past user utterances as input, and then you start decoding the next bot utterance word by word. So you feed in the first word, you get the second word as output. Then you feed in the second word, and you get the third word as output, and so on. In Chirpy Cardinal, we use neural generation for two use cases. One is personal chat. So it's a kind of conversation that you would have. Maybe you talk about their day, maybe you talk about how they're feeling, maybe you talk about some food that they had, and this is just a general social chit chat kind of a thing. The second place we use neural generation is for informative chat. So say we want to talk about the Trevi fountain and we want to add an external piece of knowledge that we found on Wikipedia, then how do we conversationally paraphrase it into the utterance is the objective of this informative chat. Well, neural generation is great. You have responsive and fluent generations, but it is also hard to control and interpret. To put it in front of users, though, it needs more work. And in the next few slides, I want to share with you some of the practical tips that went into making neural generation viable in production. So the first and the most important thing to do is to have clean training data. In our case, we took GPT-2 and fine-tuned it on empathetic dialogues dataset for personal chat and topical chat dataset for informative chat. Especially important if you're using DialoGPT, because DialoGPT has been trained on Reddit conversations, which can be pretty toxic. And so it's really important to fine tune on a clean data set before doing anything with it. This is an interesting thing that we found. So neural generation works really well if you provide a longer user response. So more substantial inputs lead to better generations. But how do you get that? So what we do is we start with a handwritten starter utterance that is designed to evoke a longer user response. It's designed so that people not only just mention like an entity, but also surrounding context with it. And we found that that really helps good neural responses. The third thing that we found was interesting and useful is to be able to sample many responses and select the one that we found was the best one. And this is not really time intensive because all of these samples can be generated in parallel. So what we do is we generate many diverse outputs by sampling tokens at each time step. So instead of taking the most probable token at each time step, we sample, say, 10 tokens at each time step. And then we can select one out of these many possible responses based on application-specific scores. Yeah, so oops. Yeah. The next one is limiting a neural conversation length. So we know that neural dialogue starts to get inconsistent over time. And to stop that from happening, what we do is we stop a neural conversation using application-specific heuristics. And then we have a rules-based transition to a different part of our bot or maybe a new neural conversation. So for persona chat, for instance, we stop after half the samples stop ending with a question. And for informative chat, we stop after the user has expressed disinterest or we have had 2 or 3 consecutive turns of neural chat. Let me check the comments quickly. Okay. If you have any questions, feel free to post them and I'll give you the mic. Yeah, and one of the other things that we found was interesting and useful was to prioritize responses with questions. So what we found was that if we ask questions as a bot, that leads to answers and it's easier to keep the conversation rolling, and these answers are easier to handle than any open-ended user utterances. While this is a good stopgap measure, there's actually work that we did afterwards that tries to fix this. But meanwhile, we did this last year, and this can lead to user fatigue and lack of user initiative. So this is the downside of something like this. All right, we'll switch gears now to the software architecture that we had for our bot. So we don't really have an int classifier sitting on top that's giving out different intents. Actually, maybe there are question. Yeah, I'll get to those at the end. Thank you. So yeah, so you might have an intent classifier sitting at the top, and then you might have it go to like say which response generator to pick, but we actually don't do that. What we do is we let all the response generators give responses. We solicit response from each of them independently and in parallel. This kind of separation allows us to have a degree of modularity between the different response generators, and like that's useful for our team, right? Because people on our team can code without knowing how the other person designed their response generator. All they need to do is sort of satisfy a certain API. So in this case, the user is talking about driver's license, and the personal chat RG says, I love listening to driver's license in the shower. Music RG says, driver's license is a great song, what do you like about it? And informative chat RG says, driver's license by Olivia Rodrigo has broken many records for popularity, whereas the movies RG just stays silent. So how do we decide now between all of these responses which one to pick? So what we do is we ask the response generators to give a self-assigned priority. So in this case, the previous response came from the personal chat RG. So the personal chat RG says, I feel strongly confident about continuing my conversation. Whereas music and informative chat RG say that they can start if there is need. And in our entire bot, we actually encourage response generators to continue the conversation as long as possible. So in this case, we select the personal chat RG's response, and then we ask that response generator, do you need a prompt? In this case, it says, yes, I need a prompt. So what that means is that that particular response generator wants to hand over to another response generator via a prompt. So in this case, we see that informative chat RG has a prompt ready to go. Would you like to hear more about driver's license by Olivia Rodrigo? And this is a contextual prompt, whereas the music RG prompt is generic. What kind of music do you like? So we select the prompt by informative chat RG, and then we use that in our response. So I would like to give a shout out to multiple people who have worked towards building and open sourcing the bot over the last 2 years. While we are all CS students, we took up a variety of roles, including infrastructure, developer tooling, template writing. There was one role in particular that I find worthwhile mentioning, that was of the UX officer. So it was a rotating role. Every week, a new student would be the UX officer, and their job would be to look at the conversations, try to understand what's wrong, and then try to fix them. Not only that, we also put a lot of time and effort into tooling. So we had integration tests, CI/CD. We also had a canary where we would try out all the new features before they would go to a broader range of users. We had a well-developed dashboard where you could look at the conversations and then drill down into how a response was generated, what could have gone wrong, what went wrong, and so on. We also had a bug tracker, and we also did code reviews of each other. So yeah, I mean, while this was a university team with limited resources, we actually ended up following some of the industry best practices. That code now is open source, so you can go online, search on GitHub for Chirpy Cardinal, and you'll find this code. This has also led to further research. So one of them is my paper on human-like informative conversations via conditional mutual information. Another collaborated with Amelia Hardy about effective social chatbot strategies for increasing user initiative. And then there is one more paper by Haugen and Dilara about large-scale quantitative evaluation of dialogue agents' response strategies against offensive users. Thank you. Thanks for all the time and attention. This you can find all the links and associated blog posts, technical articles, companion videos on stanfordnlp.github.io /chirpycardinal. And feel free to reach out on my email or on Twitter at Ashwin Paranjpe or at Stanford NLP. Thank you.
Thank you so much, Ashwin. Thanks for a super interesting talk and explaining to us how you built this system, and also fantastic to see the level of tooling and maturity around the system. I'm sure that was a big factor in your success. So one question that I had and also came up in the chat is, it's maybe still a little mysterious how exactly you calibrate these kind of confidences to continue the conversation among the response generators. Like, where does that signal come from? How do you train that, or how do you calibrate that?
That is a great question, and it's kind of different in terms of, like, we don't have numerical confidences. What we have are these 5 priority levels. So you have force start, strong continue, can start, weak continue, and no. And the way we sort of sidestep the calibration problem is we said, okay, these are the 5 things, and these are very interpretable. And all we want to do is sort of have the response generator self-assign the confidences. So I think the upside of that is you don't really need to calibrate across response generators, and I think that saves a lot of work and energy.
Absolutely, yeah. I mean, I think we've seen a lot of, like, surprise submissions where they exactly try and train that meta model, and I think that's a difficult thing to do, right?
That is, yeah.
So maybe one question I'd really like to ask is, to what extent did you investigate the ethical considerations of exposing end users to language that's generated from a large language model?
Yeah, I mean, I think there are not just like straightforward ethical considerations about toxicity and so on. There are also other kinds of ethical considerations, like do you talk about controversial topics and stuff like that. So one thing, and we had a couple of things. So we had classifiers that would avoid talking about medical advice or legal advice, those sorts of things. We also had blacklists to remove toxic speech. And I think there were cases where we sort of failed to do our job properly, but we were able to, we know that there are very few such cases. So in general, we felt like we did a decent job. But any specific ethical concerns you had in mind?
Well, I think it's a very important topic, I think, to think through, right? And my take is that it's not enough to have an approved list and a blacklist of phrases, because just the response yes can be deeply offensive depending on what the question was, right? So there are all sorts of issues, and it's not purely about generation, but okay, I want to move on maybe to some more questions. Somebody asked, is there any way to integrate Chirpy with Rasa?
I think yes. I think in general there is a way to integrate with any sort of a task-oriented dialogue system, and the way to do that would be to have Chirpy as sort of a subsystem. So you essentially pass the past few turns to Chirpy, and then it would give you the response, and then you decide whether you want to use it or not. And so you can use it as a fallback. Let's say if you know you're chatting with a user and chit chat, you can just use it as a fallback.
Cool, thank you. Okay, so a question from Josh. Since the system is still largely unconstrained, can you imagine some kind of roadmap before this is something enterprises would be happy to use?
Yes. So stay tuned. So this was all work that we did last year up to June 2020. And this year we are trying out newer strategies. So maybe to give you a sneak peek, one of them is infilling templates. So instead of having completely unconstrained generation, you handwrite few templates, but then let the neural generation tweak it so that it sounds natural and also talks about the content you want to talk about.
That sounds like a very promising approach, and probably closer to something that would get used. There's also a question: is your team involved, or is there overlap with the Ammon project at Stanford?
Yes, so we are actually actively collaborating with them. So it's part of the Oval project. And as I said, the subsystem idea, it's just straight up from there. So that's how we are thinking of it.
Yeah. Also curious, can we go on the website and see some example dialogues that happen, or are you allowed to share any?
So we can't share user dialogues, but you can actually go on the website and chat with our chatbot.
Oh, fantastic.
Yeah, so it's live. There's a link for live demo, and then you can just chat.
All right. Well, I'm definitely going to go play with that later today.
Yeah.
Question from Dutch from Russell's research team. Did you use some kind of automatic evaluation metrics to rate the quality of conversations? And did you find them to be correlated with human ratings?
I think yes. The short answer is yes. And the automatic evaluation metrics are hard to get right, but we had some classifiers that were trained for coherence, fluency, and so on, and they were correlated with user ratings. But I should also caution you that these are very limited. So lots of times they're, there's correlation at large, but you'd find a lot of variance within the correlation.
Got it. That's helpful. Thank you. Different question from Ben. Could you elaborate on your criteria for writing and evaluating the starter utterances?
Yes. So first of all, I think the starter utterances were designed so that they were not single word answers. So rather than yes, no, or providing them two choices, we let them be more open-ended. What we also tried was providing personal experiences or opinions from the bot side. And we found that elicited a higher degree of involvement from the user. And we had, for evaluation, we actually looked at the user engagement with different kinds of responses. And the second paper that I mentioned in the previous slide actually looks at how to increase user initiative. So how to write these starter utterances that increase user initiative. Yeah.
Cool.
Great questions. Thanks.
Did you have any sort of issues with asking too many questions? I remember when one of the Conv AI, I think it was like a NeurIPS workshop challenge or something, and the team that won the automatic metric evaluation didn't win the human evaluation because they just asked too many questions and user found it annoying. Is that something you noticed? Because I saw from the conversations you showed there were a lot of initiative from the bot and asking questions.
Yes, for sure. So this has been the focus this year for us, actually. So we realized that we were asking too many questions, and that was leading to user fatigue. And the good thing is that since we have a neural generation model, it's actually possible to drop those questions off and still handle the open-ended user responses that come up next. And so again, back to the second paper that I was mentioning, we tried out three strategies. One was back channeling. So we don't really say anything contentful. We just said, yeah. And then we let the user continue talking more. Or we can share something personal before we ask the question. Or we can just altogether drop the question. We can just make a generic statement. And all of those things do help user initiative. So, and helps user experience.
Yeah.
Yeah.
No, fascinating. Maybe one more question about alignment is I saw some alignment happening in the conversation, and by alignment, for anyone who doesn't know, I'm referring to like the assistant adopting some of the phrasing and language of the user. But it looked like, I think the example was about salsa, and then this Cardinal explicitly mentioned salsa. Is that alignment purely based on entities, or are there other kinds of alignment going on?
It is based on entities, but is also based on the neural model. So I think in a lot of these cases, there is a neural component to at least the first part of the response. There is also categories for the entities. So we know that salsa is a food, and how we can sort of use food related stuff. There is also, we pick up sentences from Wikipedia that are about salsa, and then we use them to generate the responses. So you get slightly more alignment. Like you can have tomatillos and you can cilantro and all of those things.
Cool. Thank you. And then probably the last question before I jump out, at least, again from Daksh. So did you try any user simulation experiments where Chirpy would talk to another open-ended dialogue model, for example, GPT-3 or something like that?
No, we did not. And so briefly, we played around with GPT-3 via their interface. I think there are difficulties around playing with another bot because the deficiencies in both the bots tend to reinforce each other. And so you end up with a dialogue that devolves pretty quickly. Whereas I feel like humans are a lot more adaptive and forgiving. And so it works better with humans than with other bots.
Well, I agree with you there. Ashwin, I'm going to jump out so we can go to the next session. You are welcome to stay. If folks have more questions, do please stick around. Otherwise, Ashwin, thank you so much for joining us. Thanks for the fascinating talk, and good luck for next year's challenge if you enter.
Thank you. Thanks, Alan, and thanks everybody for attending.